In this video course, learn LangChain and its concepts. LangChain is a framework designed to build applications powered by large language models. It provides tools and abstractions to make it easier to integrate LLMs into applications, enabling tasks like question answering, text generation, RAG, chatbots, and more. In this course, we have covered the following lessons with live running examples. Let's start with the first lesson. In this lesson, we will learn what is LangChain. We will also discuss the features as well as its use cases. Let us start. LangChain is a framework designed for developing applications powered by large language models. It simplifies the entire life cycle of LLM applications from development to deployment and monitoring. It is useful for building context-aware and reasoning-based applications. You can easily integrate LLMs into applications, enabling tasks like text generation, RAG, question answering, and others. By chaining multiple models and processes, LangChain allows a user to build complex workflows. With that, you can easily manage various components of an AI system using LangChain. Let us first understand what does LangChain interpret. It means Lang plus chain, that means large language models for Lang, as well as chain is for combining these LLMs, like chaining these LLMs. So LangChain is built around LLMs like OpenAI's GPT, Hugging Face models and others. With LangChain, you can easily chain together multiple steps or components like retrieving data from a database or document store, processing this data to generate embeddings. You can also generate responses using an LLM. With that, interact with APIs and databases. Here are the features of LangChain. You can easily integrate with LLMs. It provides a unified interface to interact with different models. Create chains of operations in which the output of one step is added as an input to the next step. For example, a chain that retrieves relevant documents and answer using an LLM. LangChain also supports memory. As the name suggests, memory is used to store and retrieve context across interactions. Through this, you can easily build chatbots or applications that require context from previous interactions, like memory. LangChain also provides tools for indexing as well as to retrieve documents. So you would be knowing about RAG. So RAG is retrieval augmented generation. LangChain also helps in building RAG systems like a vector store to retrieve relevant documents for a query. LangChain also supports agents that are systems using LLMs to decide what actions to take and in what order. Like an agent to ease the sales work, an agent that can interact with external APIs or databases. LangChain also provides tools for prompts so that you can easily manage and optimize prompts. LangChain is modular, that allows developers to mix and match components so that custom workflows can be easily built. Let us now see the use cases of LangChain. If you want to build a system for question answering, you can easily achieve this with LangChain. This will retrieve relevant information and generate answers. Easily create conversational agents that maintains context across interactions like a chatbot. Implement RAG also with LangChain so that you can get text which is more accurate and based on your own documents. You can also summarize text, easily summarize long documents or articles with LangChain. Easily build tools so that codes can be generated. With that, easily create personal virtual assistants for tasks like scheduling, retrieving information, drafting an email, and others. So in this lesson, we saw what is LangChain, its features. We also saw the use cases. Thank you for watching the video. In this lesson, we will understand what is chaining in LangChain. We already saw how to interpret LangChain like lang plus chain. So let us see what is chaining. LangChain is a process to combine multiple components or steps into a sequence so that you can fulfill a specific task. Chaining is important so that you can mix and match components to ease the work of creating custom workflows, easily build systems that use context from previous steps like chat history. With that, you can also easily break down difficult tasks into smaller, easier steps with chaining. Here is a quick example of chaining in LangChain. Let's say you are building a RAG, that is retrieval augmented generation system. In this, what is the first step? That is retrieve. You can use a retriever to fetch relevant documents. Then the generate, pass the relevant documents, and a question, that is a prompt asked to an LLM to generate an answer. And what will be the output? The answer will be returned to the user. So the sequence of steps we saw is a chain that combines retrieval and generation into a single workflow. So this is the concept of chaining. Chaining is like linking multiple components together to create a sequence of operations like document retrievers. So guys, we saw what is chaining in LangChain. Thank you for watching the video. In this lesson, we will understand what are the components of LangChain. Also consider them as the modules of LangChain. Let us see. To build complex workflows, including LLMs, LangChain has provided some components. Let us see them. The first is preprocessing. As the name suggests, it prepares your raw data like your documents so that you can use them in LangChain workflows. It also includes the task of splitting text into chunks, cleaning the data and generating embeddings. Then comes your models. These are your LLMs, that is large language models, or even the embedding models. You must have heard about GPT, also Hugging Face models. With that, it also includes your custom fine-tuned models. Then comes the prompts component. These are like your queries or instructions, or consider them as the input which is given to the LLM to generate responses. These are like the prompts you type on ChatGPT. It can be static or dynamically generated based on context or user input. Then comes memory. As the name suggests, it stores and retrieves like your chat history. It also enables applications to maintain continuity and context awareness. Chains, as we discussed before, it is to combine multiple components into a sequence of steps. The idea is to pass the output of one component as the input to the next, forming a structured workflow. Through this, you can easily work around complex workflows like question answering, text generation, summarization, etc. Indexes. These are the tools for organizing and retrieving data efficiently. You can relate it with the layman definition of indexes. Why we use indexes? So that we can retrieve the data quickly. In this also, you can easily enable fast retrieval of relevant information. Agents. These are the systems that use LLMs to decide actions and interact with external tools or APIs. With this, you can perform tasks like calling APIs, querying the database, and others. So guys, we saw what are the components of LangChain. In the upcoming lessons, we will discuss them one by one. And after that, we will see a live running example of LangChain. In this lesson, we will understand the first component of LangChain, that is preprocessing. Let us see. As the name suggests, the LangChain process begins with document loaders and text splitters. This can include PDF documents. The loading and pre-processing of data is what the pre-processing component includes. After this, the output is passed to other components like models, indexes, and chains. Generally, under the LangChain components, this component of document loaders and text splitters are not included, but this is still an essential part of the LangChain ecosystem. This eases your work in building workflows. So why we should start with the document loader and text splitter step? So this is the data ingestion step. It includes the entry point for bringing your external data into the system. The role of text splitters is to ensure that your data is in correct format so that it can be easily processed by the model, whether it is LLM or embedding model. When you split the document into chunks, it allows for parallel processing and efficient retrieval. With that, you can also achieve scalability. Splitting the data allows you to handle large data sets. Guys, we saw what is the pre-processing component of LangChain. In this lesson, we will understand what is the models component of LangChain. Let us see. Models, as the name suggests, refers to your LLMs, that is large language models. It can also include your embedding models. These models are actually responsible for managing, understanding, generating, and transforming text based on the input received. Let us see the types. The models in LangChain can include LLMs, and it can also include the embedding models. Some of the examples of LLMs are the GPT models, Meta's Llama models. They are the brains of LangChain applications so that you can perform text generation, text summarization, translation, problem solving, and others. It has the capability of generating human-like text. It can also answer questions, summarize content, and perform other operations. Then comes your embedding models. This is used to convert your text into numerical representations, that is embeddings. This is used for tasks like document retrieval, clustering, so that you can easily enable systems to find relevant information at a fast pace. Now let us see why these models are important. They actually provide the intelligence and are the brain behind LangChain applications. So that tasks like creating content, summarizing text, question answering can be easily achieved. By combining both the LLM as well as your embedding models, LangChain can be used to build powerful systems. So guys, we saw what is the models component in LangChain. In this lesson, we will understand what is the prompts component of LangChain. Let us see. So prompts are basically the input queries, instructions or context you provide to the LLM. Whenever you type a prompt on ChatGPT or Copilot, so this is what we call a prompt. This basically acts as a bridge between the user and the LLM, and it actually allows the model to interpret and respond to a specific task. What is the role of prompts in LangChain? We all know what is a prompt. We got a lot of answers on typing prompts on Copilot, Claude AI, ChatGPT, Gemini, and many other chatbots. But what is the role of prompts in LangChain? It actually guides the LLM while answering a question or while summarizing a text. These prompts can also include an additional context like chat history, retrieve documents, and others, so that the relevance can be enhanced and to make the response of the LLMs more accurate. With that, you can also customize your prompts according to specific tasks or domains. This makes them highly flexible. So why prompts are important in LangChain? They actually determine how the LLM interprets and responds to a task. This helps in achieving more accurate and relevant outputs. If the prompts are Well designed, it can significantly enhance the performance of LangChain applications. Well designed prompts help in complex workflows like RAG, chatbots, or others. So guys, we saw what are prompts and the role of prompts component in LangChain. In this lesson, we will understand the memory component of LangChain. Let us see. As the name suggests, the memory refers to the ability to store and retrieve context across interactions. So the system remembers previous inputs, outputs, or other relevant information. So there are two types of memory, short-term and long-term. As the name suggests, if the context is stored for the duration of a single interaction or session, it is called short-term memory. Like remembering only the previous question of a user in a chatbot so that the flow of the conversation is easily maintained. Then comes your long-term memory. It stores context or data across multiple sessions or interactions, like saving the historical data of what a user types in a chatbot so that personalized responses can be generated. This also helps in saving user preferences. Why is memory important? It easily allows multiple interactions so that the system can reference previous inputs or outputs. This eases the work in providing more relevant and accurate responses. If you are building conversational agents, personal virtual assistants, then memory is really important. So guys, we saw what is the memory component of LangChain. We also saw the types. In this lesson, we will understand the chains component of LangChain. So these are sequence of operations or steps that combine multiple components. This is like passing the output of one component as the input to the next so that a structured workflow is formed. Here are the two types of chains, simple and complex. When each step is executed one after the other, it is called a simple chain. This is like a linear sequence. For example, a chain that retrieves documents and then generates a summary. Then comes your complex chains. These are non-linear and can include branching, looping, or decision making. For example, a chain that retrieves documents, it also evaluates the relevance and generates an answer. Why chains are important? They provide a structured way to arrange complex workflows. Through this feature, you can easily build complex applications. They also enable modularity and reusability so that the developers can mix and match components for different use cases. So guys, we saw what is the chain component of LangChain. Thank you for watching the video. In this lesson, we will understand what are indexes component of LangChain. Let us see. If you want to store data in a way that allows efficient and quick retrieval of data, then use the indexes. In a similar way, indexes in LangChain are tools for organizing and storing data that enables efficient retrieval and search. They make it easier to find relevant information quickly and act as a structured repository for documents and embeddings. Here are the two types of indexes, vector and document. The vector indexes store numerical representations, that is embeddings of text, to enable semantic search and similarity based retrieval, like a library FAISS for efficient similarity search of dense vectors. The second type is document. It stores raw documents or text chunks like a database of PDFs or articles indexed by title, author, or topic. Why are indexes important? For retrieval based tasks, these are really important. and enables systems to quickly find and use relevant information. These are important for building efficient applications which are scalable. If you're dealing with large data sets or complex queries, then the index component really helps. Guys, we saw what are the indexes component of LangChain. We also saw the types of indexes. In this lesson, we will understand the agents component of LangChain. Let us see. Agents are AI-powered systems that use LLMs to decide which actions to take. They act as intelligent decision makers that dynamically interacts with tools, APIs or data sources to achieve a goal. Here are the two types of agents, single action and multiple action. The single action agent perform one specific task or action based on the input, like an agent that retrieves weather data from an API. The second one is multi-action. Using the multi-action agents, easily perform a sequence of actions iteratively to solve complex problems. Like an agent that plans a trip. So what are the things required to plan a trip? Like an agent is used to book flights, hotels, and even the transportation. Why are agents important? They are important because autonomous and intelligent behavior is enabled. This allows system to handle complex multi-step tasks without any predefined workflows and independently. If you are building applications that require reasoning, planning or interaction with external systems, then agents are quite useful. So guys, we saw what are agents in LangChain. We also saw the types. Thank you for watching the video. In this lesson, we will understand the workflow of LangChain with RAG. We will see how LangChain can be used with RAG. Let us see. Previously, we saw various use cases of LangChain as well as its components. So let us now see a workflow displaying how LangChain can be used to build a RAG system. You can also relate this with the components of LangChain we just discussed. First, we load PDFs into document objects. These are called document loaders. Then the documents are split into chunks, that is text splitters. After that, embeddings are generated for the chunks, that is with the embedding models. Then the embeddings are stored in a vector store. After that, the retriever and LLM are combined into a QA pipeline with chains. Using prompts, the user's question is passed to the QA chain. After that, the vector store is used to retrieve relevant chunks. So this is the basic workflow. We will see the complete code in the upcoming lessons. So guys, we saw a simple basic workflow to understand LangChain with RAG. Thank you for watching the video. In this lesson, we will see the process of LangChain with RAG. Okay, we will discuss step by step that how LangChain with RAG is implemented. Let us begin. We just saw the LangChain with RAG workflow. We will just use the same to implement LangChain with RAG. First was document loaders. These were responsible for loading data from various external sources like uploading a PDF or multiple PDFs, databases and others. So for that, in our code, we will use the PyPDF loader to load PDF documents. Then comes your text splitters. In this, we break down the large documents into smaller chunks so that it can be processed by LLMs. For this, we have used the recursive text splitter to split documents into chunks. Then comes models. These are the LLM models or embedding models. For that, we have used the Hugging Face embeddings class for the embedding model. This is used to set up the embedding model. In our case, we have used the sentence transformers. For LLM, we have used the Hugging Face pipeline class so that we can set up the local LLM. In this case, we have used the following. Then comes your prompt. This is the input query or prompts used to interact with the LLM. We already discussed. For that, we have created a custom function answer underscore question so that it takes a question as input and acts as the prompt for the QA chain. Then comes your memory. This is to store intermediate data or context. In this implementation, we have not used memory, but the vector underscore store and document underscore chunks can be considered as part of memory. Chains. This is a component that refers to the sequence of operations. The retrieval QA chain is used in our code to combine the retriever and the LLM. Indexes. The FAISS vector store is used to index the document chunks. This helps in indexing of documents for efficient retrieval. Agents. This component refers to the decision-making entity that interacts with the system. In our code, we have used the local RAG system class that acts as a high-level agent, planning our workflow. So guys, we saw the process. Now in the last lesson, we will see the coding example and run our LangChain with RAG system on Google Colab. In this lesson, we will see the final coding example to implement LangChain with RAG. We will see the code and also understand the steps in the form of code snippets, and in the end we will also run the code. We will upload more than one PDF and summarize it using our LangChain with RAG system. Let us start. So here is our Google Colab. We created a new notebook and here is our code. So let us understand the code. First, we will install the necessary packages. I hope you know that in Google Colab we use the following command to install any library or package from the Python package index. Here we are installing the necessary packages like LangChain, sentence transformers. The code then imports various modules and classes from these packages, like here. Okay. The imported modules enable functionalities such as text splitting, document loading, embeddings, and language modeling. Now let us set up logging here in step 2. This code is used to configure the logging module in Python. The first line here sets the basic configuration for the logging module. The following line creates a logger instance. The get logger returns a logger instance. Here the following is a built-in Python variable that holds the name of the current module. In the first line, this function is used to configure the logging module. The following sets the logging level to info. This means that all log messages with the level of info or higher will be processed. Now we will create a class representing a local RAG system. Let us now initialize the local RAG system object using init. Okay. Here the documents, consider it as a list to store the loaded documents. Vector underscore store stores the embedding documents. Now we will upload PDF from the local machine to Colab. The following function files.upload is used for this. The uploaded file names are logged and returned. Any exceptions during upload are caught, logged and re-raised. Okay. The method is part of a class and uses a logger for logging messages. It returns a list, that is a list of uploaded PDF paths. Then comes your load underscore documents function. This will load and parse the PDF documents. It defines a load underscore documents method to load and parse PDF documents from given file paths. The following iterates through each PDF file path, attempts to load the document using PyPDF loader, and appends the loaded pages to the self.documents list. Any exceptions during loading are caught, logged, and the method continues with the next file. The number of loaded pages for each file and the total number of pages are logged. The method updates the self.documents list with the loaded document pages. Now the next step, to split documents into chunks. This method will split loaded documents into chunks using recursive character text splitter. The splitter divides the documents into chunks which are stored in self.document underscore chunks. That is here. It takes optional parameters chunk underscore size and chunk underscore overlap. The default is 1000 and the default for this is 200. The number of chunks created is logged. Next step, set up the embedding model. This code sets up the embedding model using Hugging Face transformers. It takes an optional model underscore name parameter. The chosen model is used to create a Hugging Face embeddings instance. The setup process is logged including the model name. Any exceptions during setup are caught, logged, and re-raised. Then the next step. In the next step, we will create a vector store from the document chunks. This code creates a vector store from document chunks using the FAISS. It uses the previously set up embedding model to generate vectors from the document chunks. FAIS dot from underscore documents method creates the vector store. The creation process is logged and any exceptions are caught, logged, and re-raised. In the next step, we will set up a local LLM using Hugging Face. This code sets up a local large language model using Hugging Face transformers. It loads a pre-trained model and tokenizer using the specified model underscore ID. A text-to-text generation pipeline is created with the loaded model and tokenizer. The pipeline is wrapped in a Hugging Face pipeline instance and stored in self.llm. The setup process is logged and any exceptions. The setup process is logged and any exceptions are caught, logged, and re-raised. Now let us create a QA chain using the vector store and LLM. This code sets up a QA, that is a question answering chain using the vector store and LLM. It creates a retrieval QA instance with the specified element and vector store as retriever. The retriever is configured to return the top K results. The QA chain setup process is logged with the value of K. Any exceptions during setup are caught, logged, and re-raised. Now we will answer a question using the RAG system. The following code defines a method to answer a question using a RAG system. It takes a question as input and uses the QA underscore chain to generate an answer. The question and answer are logged for tracking purposes. The answer is returned by the method. Any exceptions during the answering process are caught, logged, and re-raised. Now let us run the complete setup process. Okay. This code defines a method run underscore setup to execute the complete setup process for a RAG system. It calls various methods in sequence to upload PDFs, load documents, split documents, set up embeddings, create a vector store, set up a local LLM, and set up a QA chain. This method takes optional parameters to customize the setup process. The completion of the setup process is logged. Any exceptions during setup are caught, logged and re-raised. Now here is the example usage. This creates an instance of the local rack system and runs its setup process. The setup process configures the system with specific parameters such as chunk size and language model. After the setup, the code asks two questions. The first one is here and the second one is here, and prints the answer. The questions demonstrate the system's ability to understand the main topic and summarize key points from the documents. The answers are successfully generated using the rack system. So here what I'll do, I'll just run the complete code. You can also select runtime from here, select change runtime type and select T for GPU and click save. Now I'll run it. Let's wait. Now here let us upload the documents. Click choose files. So let's say I'll upload Amit sample.pdf and Python certification. I'll click open. Now we have uploaded two documents. It will now extract the result. It is displaying the main topics as well as it summarized the key points from the documents. So in this way guys, we can work with LangChain. We saw LangChain with RAG example. Thank you for watching. Guys, if you liked the video, you can directly go to our channel and support us by subscribing and joining. Click on the join button. Herein you can support us, okay, by clicking join here. And you can also go to any of our video, okay, herein click on the three dots and click thanks. You can also directly support us here, okay. Thank you for watching.